figure out whether this stereocenter is R or S. First of all, you have to find the stereocenter. This is the stereocenter. It's attached to 4 different things. It's attached to a hydroxy group. It's attached to a hidden hydrogen. Remember, it's always a good idea to draw in the hidden hydrogen on the stereocenter. It's attached to this carbon down here, and it's attached to a double bonded carbon up there, which indicate 2 different things. Now we'll put in dots to show the atoms we're comparing when we're finding priorities. Clearly, the hydroxy oxygen takes the number 1 priority, and the hydrogen takes the number 4 priority. Now, these 2 carbons are tied, so we list the 3 things they're attached to. This carbon's attached to a carbon and 2 hydrogens, hidden hydrogens, and this carbon is double bonded to a carbon. Remember that we treat the double bond as 2 separate carbons, and there's also a hidden hydrogen. Because of the double bond, we pretend that this is bonded to 2 separate carbons. And now the first point of difference is the second atoms in the list. This carbon beats this hydrogen. So here we get the number 2 priority, and down here we have the number 3 priority. Once again, we've been very fortunate that the number 4 is pointing into the page already, so we can just look to see what the configuration of 1 to 2 to 3 is. Starting at number 1, then moving to number 2, then to number 3, then back to number 1. You can see that now we're moving in a counterclockwise direction. Counterclockwise is indicated by an S. So this stereocenter would get the S designation. For most of the molecules that we do, I'm not going to bother to give the full IUPAC name like we did over here. Instead, we're just going to determine whether the stereocenters are R or S. But remember that if you did give the full IUPAC name, part of that name that you would have to include is whether each stereocenter is R or S. By the way, I didn't specifically point this out, but notice that the first 2 examples we did were Fisher projections, and the second 2 examples that we did were not Fisher projections. So the good news is that this same method works regardless of the diagram. It works both for Fisher projections and for non-Fisher projections. Also, it works for straight chain molecules, and it works for cyclic molecules. So it doesn't matter whether you're working with a straight chain or a cyclic, with a Fisher projection or a non-Fisher projection. As long as the number 4 priority is pointing away from you, you can use this straightforward method. Well, now we've completed our discussion of what to do when the number 4 priority is pointing away from you into the page. We've discussed the mechanical method that allows you to determine whether the stereocenter is R or S if the number 4 priority is pointing away from you. But remember, there's really 2 different cases we need to deal with. We have to learn what to do when the number 4 priority is pointing into the page, and case 2, we have to learn what to do when the number 4 priority is not pointing into the page. Well, now we're done with case 1. We know what to do when the number 4 priority is pointing away from you into the page. Now, as we proceed with the videos, we have to move on to case 2. What do you do when the number 4 priority is not pointing away from you?